Have you ever looked up at the moon and thought, wow, that's far? It is. The average distance from Earth to the moon is about 239,000 miles, or 384,000 kilometers. A round trip? That's nearly 500,000 miles. It's a journey that pushed humanity to its limits. But what if I told you that entire monumental trip going to the moon and coming all the way back doesn't even cover the distance from one side of our sun to the other? It sounds crazy, right? But it's true. The diameter of the sun is a staggering 865,000 miles, or about 1.4 million kilometers. So, you could fit the entire Apollo mission's round-trip journey to the moon inside the sun with plenty of room to spare. Think about that for a second. The greatest journey humanity has ever undertaken is just a fraction of the size of our own star. This simple comparison completely changes our perspective on scale. Our giant leap for mankind is, in cosmic terms, just a tiny step. Let's visualize this. Imagine the Earth is the size of a small marble. On this scale, the moon would be a tiny peppercorn about 2.5 feet away. Now, imagine the sun. On this same scale, the sun would be a massive ball over 8 feet tall, located almost 2 football fields away from our marble-sized Earth. The round trip to that little peppercorn seems insignificant when you picture that giant distant sphere. And here's the mind-bending part. Our sun isn't even a particularly large star. It's classified as a yellow dwarf. It's pretty average, maybe even on the smaller side when you look at the galactic neighborhood. There are stars out there that make our sun look like a grain of sand. Let's meet a few of these cosmic giants. Take a star like Betelgeuse, the bright red one in the Orion constellation. Betelgeuse is a red supergiant. If you were to place Betelgeuse where our sun is, its surface would extend out past the orbit of Mars, and maybe even Jupiter. Earth, Venus, Mercury, and Mars would all be inside the star. It's so enormous that our sun would be a microscopic dot next to it. The distance to our own moon and back wouldn't even register, but we can go bigger. Let's talk about UY Scuti. For a long time, this was considered the largest known star. It's a hypergiant. Its diameter is estimated to be about 1/700 times that of our sun. Let's try to wrap our heads around that. If UY Scuti were at the center of our solar system, it would engulf everything up to the orbit of Saturn. Jupiter, with all its size and majesty, would be deep inside this colossal star. The speed of light is the fastest thing in the universe, right? It takes light from our sun about 8 minutes to reach Earth. To travel just once around the equator of UY Scuti, that same beam of light would need nearly 7 hours. Our sun? Light takes less than 15 seconds to circle it. The difference is just astronomical. And even UY Scuti has been challenged for the title. This exploration of scale doesn't just apply to stars, it applies to distances too. Our solar system is a big place, but it's just a tiny speck in our galaxy, the Milky Way. The Milky Way is a spiral galaxy containing anywhere from 100 to 400 billion stars. It's about 100,000 light-years across. A light-year is the distance light travels in a year, which is almost 6 trillion miles. So, just to cross our own galaxy would take a spaceship traveling at the speed of light 100,000 years. Our trip to the moon, which took the Apollo astronauts a few days, is a blink of an eye in comparison. And our galaxy? It's just one of billions, maybe even trillions, in the observable universe. The Milky Way is part of a local group of galaxies, which is part of the Virgo supercluster, which in turn is part of an even larger structure called the Laniakea supercluster. It's like a cosmic nesting doll, with each layer revealing an even more immense and humbling reality. When we talk about the edge of the observable universe, we're talking about a distance of about 46.5 billion light-years in every direction. So, let's bring it back. That trip to the moon and back, that 500,000-mile journey that represents such a pinnacle of human achievement, is dwarfed by the diameter of our very own, rather average star. And that star is just one of billions in a galaxy that is itself just one of billions. Thinking about this can feel overwhelming. It can make you feel small and insignificant. But I think there's another way to look at it. It's a testament to the incredible power of the human mind and spirit. Here we are, on this tiny blue marble, with brains that evolved to hunt and gather on the plains of Africa, and yet we are able to comprehend these scales. We can build tools that let us see these distant giants and measure their size. We can use mathematics and physics to understand the laws that govern them. The fact that we can even have this conversation, that we can know about stars like UY Scuti and the sheer vastness of the cosmos, is a miracle in itself. It doesn't make us small, it makes our consciousness incredibly special. We are the universe's way of knowing itself. That drive to explore, to understand, to look up at the moon and not just see a light in the sky but a destination. That is what makes us human. So the next time you look up at the night sky, remember the scale. Remember that the round trip to that beautiful moon is smaller than the star that warms our days. Let that fact fill you not with a sense of smallness, but with a profound sense of wonder and curiosity. It's a reminder that there is always more to explore, more to learn, and more to be amazed by. The universe is vast and full of wonders, and we've only just begun to scratch the surface. Thanks so much for joining me on this cosmic journey today. If you enjoyed this and want to explore more mind-bending facts about our universe, please hit that like button and subscribe to the channel. It really helps us create more content like this. Until next time, keep looking up.